everyone. Welcome to Gannon University. I'm Lori Lindley. I'm the Dean of the College of Humanities, Education, and Social Sciences, and I'm so glad to see all of you here to join us for tonight's event. We're so proud to partner with the Jefferson Educational Society in hosting the 17th Annual Global Summit Speaker Series. We deeply value their mission to bring programs of such global significance to our community. We're grateful that so many of our students, faculty, and staff can attend these events and engage in the programs and workshops associated with the Global Summit as part of their educational and professional journeys. At Gannon, we are committed to preparing our students to become global citizens, and we are honored to partner with the Jefferson Educational Society to create opportunities for meaningful dialogue and discovery both within our university and with the broader Erie community. As a university, we are inspired by tonight's topic, Humanity 2050, the future of our world, our universe, and ourselves. This event invites us to imagine what lies ahead and to reflect on the profound questions shaping our collective future. It encourages us to explore the intersection of science, technology, ethics, and human purpose, and to consider how these forces will influence our understanding of humanity and impact our own lives. We're delighted to have you here this evening as part of that conversation. It is now my pleasure to welcome Dr. Farki Farhadi, President of the Jefferson Educational Society, to welcome tonight's event sponsor.
Good evening, folks. How's everybody doing tonight? Good. We are here to talk about the future and what that means for us here in Erie and for the nation and for the world. But being Veterans Day today, I know that whatever future brings, our military and our veterans have paved the way to get there. So thank you for your service. Thank you for what you did to our nation. I am one of the folks that had the privilege, or not the privilege, but the privilege of seeing the military, the United States military in action in a war zone, because I came here from Kosovo as a war refugee, and the United States intervened. And I tell you, folks, I saw, because this was a sort of worldwide effort to bring peace to the Balkans, and you can tell the difference between our military and the rest of the world, because our military is about bringing freedom to individuals everywhere. So we owe it our thanks. I personally owe you my freedom. Thank you for your service. And I have made it my life's mission to pay it forward for the opportunity that you've given me. I want to thank our team at the Jefferson and our volunteers, legions of volunteers, our hosts here at Gannon University, for all the work they do to bring this program together. Having 22 speakers here over a month and a half is quite the work, and our team makes it look easy. So let's give them a round of applause. And I do want to recognize two individuals who we make them wrestle on who is going to interview who, moderate in discussion, and that is Ben and Steve, and what they do for us, and the additions that they bring to our programs is really incredible. And I think tonight Ben won, right, Steve? Sorry about that. And of course, our sponsors, our folks, our very good friends at Erie Insurance. Thank you for what you're doing for the Jefferson and for the community. And thank you. Our partnership with Erie Insurance has really ignited a renaissance for our community. And we're just so happy that you stuck by us all these years, 17 years later, and we keep on growing, and the series keeps growing because our sponsors enable us to. Because as you remember, there's no inflation at the Jefferson. Tickets have been $25 and free for students for all 17 years, and that's because of our sponsors. And tonight, representing Erie Insurance, it's a Balkan takeover, by the way. Kosovar, Bosnian, please welcome to the stage my good friend, Sandra Imamovic.
Thank you very much, Berkey. Good evening, everyone. My name is Sandra Imamovic, and I work in the Sustainability and Community Development Department at Erie Insurance, specifically in the area dedicated to inclusion and belonging. As I reflected on tonight's session, I wanted to connect the work our organization does to the work of Dr. Charles Liu, including the importance of being curious and asking questions of others and getting to know their stories, and broadening our perspectives by embracing diverse ideas as we can draw strengths from our varied experiences. As you listen this evening, I encourage all of you to do the same and make those same linkages. No matter where we come from, what we look like, or what we believe, we all share a common cosmic origin, reinforcing the sense of shared purpose and universal belonging. When we look up at the sky night together, we all become one under the vastness, deeply connected and unified. As the American Museum of Natural History tells it, Dr. Charles Liu was deeply involved in developing the museum's cosmic pathway, a ramp representing all of time, starting with the Big Bang. As visitors walk along the spiral pathway, they pass through 13 billion years of history, from the origin of the universe up to the present day. The human condition is filled with angst, Charles observes. It's filled with all of these questions. How do we get here? Where are we going? Are we alone? He believes that having a cosmic perspective can help alleviate this angst in some small way. If the cosmic pathway represents more than a football field long, all of human history falls within the width of one human hair. It shrinks your head, Charles notes. If you've had a bad day, it's not that big of a deal. Which leads to tonight's topic, Humanity 2050, the future of our world, our universe, and ourselves. What about the universe might change? How will people evolve? Dr. Liu may be the best prepared Earthling to answer these profound questions. The Taiwanese-born American scholar and researcher is an astronomer, educator, author, and science communicator. He is a professor and chairman of physics and astronomy at the College of Staten Island, the CUNY Graduate Center, and associate at the Hayden Planetarium of the American Museum of Natural History. Among his passions is mentoring the next generation of scientists. Please join me in giving a Jefferson Global Summit welcome to Dr. Charles Liu.
Thank you so much, everyone. It is a real pleasure to be here. As I told Steve when he first suggested that I come here, I immediately said yes because I wanted to come to Erie. Really? Yeah. Our conversation today is indeed, just as Sandra has said, a discussion about what we're going to be like someday in 25 years. I have had the good fortune to experience 2 of these 25-year periods in my life. And so some of the things that I remember thinking back then, watching how they've played out, have given me the desire to think about what's going to happen in the next 25 years. And just to understand what we can do about it is the subject of the conversation today. But it is a conversation. I only intend to speak for about half an hour. Okay, so everyone go ahead and set your alarms and everything. At 30 minutes, beep, 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 and I'll just stop talking, okay? In the meantime, you all should have index cards. Please write down any questions you want us to discuss afterwards, because we're going to leave the bulk of the time today for conversation, because that's what's most interesting to me, to try to answer the questions that you all might have, okay? By the way, studies have shown that when professors pause to ask any questions, they pause for, on average, less than 1 whole second before they go on. Think about it. So don't wait for the question asking moment to think of your question. The moment it comes up in your head, write it down, okay? Write it down, put your name on it if you'd like. If we don't get to it on stage later, I will take the stack of unanswered questions home, and we'll see if we can put it on a future episode of the podcast, all right? So we want to get everybody's questions in, no matter what. Even if you think it's trivial, even if you think it's been asked before, please continue to ask it. I assure you it is valuable and meaningful for you to make that. For these days, in the age where we can get an answer to anything with the swipe of a finger on a screen, it is the questions that will matter more than the answers. So if we talk about this future, right, we can't talk about all of it in half an hour. So I'm just sticking to 3 things, okay? Our world, our universe, and ourselves. And what does that mean? This is our home. All of us, as Sandra was saying, we all live under one sky. Every human being that's ever looked up has seen the same sky, just at a different time or a different place. We are truly unified. We know further from our scientific studies of the universe that we are part of the universe. We are made up of the same stuff that every star in the sky is made up of, or every galaxy in the cosmos. So in that sense, we are as awesome and as ordinary as everything you see out there. So we matter. When we are thinking about the future, it is important for us to think about the future, not just of them or us, but of us all. The interconnections and the linkages, the sense that you belong here, that you are part of the universe, you matter, should infuse everything that we think about. Because so does your neighbor, so does your child, so does your parent. They all matter one way or another. So what will we be like in a quarter of a century? Great question, right? I have thought a lot about this. I've tried to do a lot about it. And so I'm about to tell you this. But before I do, you have to believe me, don't you? Predictions are a dime a dozen, right? Everybody can make a prediction. I, for example, had this mild prediction that this weekend, the Bills, the Browns, and the Steelers would all win. The exact opposite happened. Right? So when you hear someone make a prediction or make a promise or make a statement, how much should you believe that statement? And why should you believe it at all? I'd like to spend a few minutes to sort of explain to you why I think that you can believe me at least a little bit. And I hope that anytime you hear any such prediction or promise or a statement for the future, you use this same kind of filter that I'm about to tell you what I used to give yourself some confidence that this isn't just a confidence game being played on you. The concept of scientific prediction is not just about what I hope or I think or I believe or I want you to believe, right? It's instead something that's built to try to insulate us from that very impulse. We humans, as has been shown both scientifically and throughout all of history, are very vulnerable to deception and manipulation. Even when we think we aren't, our brains are very complicated. Our patterns of behavior date back to before we were even Homo sapiens sapiens. The way our brains work, the way our nerves work, the way our bodies work, all are highly influenced and influenceable by things that are not real, by things that will move us and twist us in bad directions. Especially bad is what I call pseudoscience. Some people call it fake science. Some people call it, whatever they want to call it. But it's when you use scientific terminology or some sort of philosophy to try to convince people something that is wholly unscientific. Now, non-science is fine. In fact, it's great. Most of our lives, if you think about it, is run by non-scientific ideas. And they may well be true, but it just doesn't necessarily mean that they are believable, right? Or they can be used in a way that can help us in the future. I myself have a non-scientific belief. True love conquers all. Okay. I believe it to be true based on information I've had in the past. But I can't prove it. So I can tell you that's what I believe, but should you believe me? Right? So please, always go through this thought process when you are listening to people's scientific or pseudoscientific predictions. Facts, pieces of information all around, the bedrock of what we know, things we have observed and measured. You organize those facts first, and we call that data. When you organize information and facts into things that we can then analyze and try to answer for questions, then we guess. And you're like, wait a second, you're not supposed to guess. That's not very smart. That's not very scientific. Nay, as it turns out, educated guesses are where we go. That's what science fiction is, right? That's what all imagination is. We're guessing. But if you are doing it scientifically, you inform that guesswork. It's an educated guess. And in our language, we use the term hypothesis, right? Greek for not an idea or an empty idea. It's something that we haven't been able to confirm yet, something we haven't proven or shown. But those hypotheses are what drive us. They say, hey, I think this is why it works. Now I'm going to go further and test it and see if my prediction is true. When that happens, if you test your hypotheses rigorously, you demand the possibility that you fail. You make it so that you've designed your question in your experiment to say, I could be wrong, and I want to prove that I'm wrong. But if I fail and instead prove I'm right, then I have something called a scientific theory. Okay. Again, the word theory in our lives is invented, right? Well, the Steelers lost. Well, I have a theory about that, right? It's quarterback, it's coach, it's whatever. That's like our normal way of talking about theory. But in science, a theory is Albert Einstein's general theory of relativity, right? A theory of evolution, not just what Darwin did at first, but the hundreds of scientists and decades after Darwin first proposed the hypothesis of evolution by natural selection, building up the theory from there, right? Being tested over and over again, and yet shown it still to be correct. Same thing with Albert Einstein's general theory of relativity, right? We have tested it over and over again, and it still comes out right. Doesn't mean it's unfixable. There's still things that need to get better. We always know that our theories, because they come from educated guesses, are limited. They're not all-encompassing. And therefore, we have theories that we can believe as far as we can throw. Right? We understand our limitations because we ask the question that way. So scientific prediction honestly follows that process. Facts to data, to hypothesis, to testing, to theory. Scientific prediction earnestly invites scrutiny. I publish my results on colliding galaxies and supermassive black hole activity, right, inside starbursts and post-starburst systems. I tell everybody what I did, and I say, please, ask me questions so that I can answer them. They say, well, have you thought about that? Did you do that? Did you do this? Did you do that? I welcome it. I want to answer these questions. And if someone stumps me, I'm like, oh, thanks. I got to go back and fix something. Or I got to go get some more data, right? And most importantly, perhaps, a scientific prediction humbly, in the eyes of ignorance, in the face of we don't know, we acknowledge its limits. If someone says some brand new, grandiose thing, this is the reason for everything, right? That's not science. That's just bloviation? Is that the right word to use? I'm not an English major. So please, for the rest of my talk and our conversation up here, make sure that everything we talk about has come from this process, from these scrutinous measurements, and from the humility of knowing I don't know it all. Sound good? So with that, oh yeah, thanks. With that, here we go. What will it be like? What will we be like in a quarter century? There is not a clock back there, so I'm going to use this to make sure that I'm on time. Like I said, I'm going to set an alarm now. Isn't it great? Technology is awesome. You don't have to sit here wondering, boy, the guy's going on and on. When is he going to stop? I am setting the clock for exactly, well, I already talked for like 5 minutes, right? So I'm going to set the clock for 25 minutes. If this goes off, I will say thank you very much. Okay, prediction. Well, like I said, we only have time for 3 of them. But these 3, I hope, will encompass the kinds of things that we can use as a springboard to discuss all the questions that you have going forward. Prediction number 1, we will be able to learn if extraterrestrial life is somewhere on another world. Now, notice what I said. Again, that humility here. We will be able to. Will we find it? I don't know. I am pretty sure that scientifically speaking, the odds that life exists somewhere in the universe that did not originate on Earth, like we and our animal and plant friends did, right? The odds of that happening are high. But the odds of our finding it are very, very low. So what we are going to be able to do is legitimately, in 25 years, be able to find life on planets and moons in our own solar system. Already, we have spacecraft that are able to land on these places and look for rocks or biosignatures and things like that, right? We've only been able to find biosignatures, though, not actual bioorganisms, okay? And that's why every time you hear something like, oh, the Mars Perseverance spacecraft has found a thing, yeah, right? But then the scientists say, well, that's a biosignature, maybe. And then there are people working on trying to figure out if these biosignatures are actually things that are only caused by life, or indicative of life, but not necessarily, or even just a wrong measurement, right? They undergo intense scrutiny, not because we want to cover up the discovery of aliens, but because we want to make sure that we got it right. So I'm just going to talk about the person on the left of this picture. I was giving a talk in Trenton, New Jersey, actually, earlier this summer. And it was about the Vera Rubin Observatory, a project which is near and dear to my heart. We're going to talk a little bit more about that later. This is the best ground-based telescope system that's coming online now. Over the next 10 years, we're going to be gathering a real-time movie in slow motion of the entire sky. And then over the next 15 years, we're going to be studying it and measuring it so carefully and looking for all kinds of cool stuff, including biosignatures. So I'm just going to talk a little bit about this Vera Rubin Observatory. And when I went to Trenton at the State Museum there to give a talk on this very subject, I was told that Vera Rubin's younger cousin was coming to the talk. I was like, this is cool, right? She came, introduced, it was such a pleasure to talk to her, and she said, oh, by the way, I have some pictures. This picture, as the thing says here, is 1938. The young lady on the left is Vera Rubin. Grew up in an immigrant Jewish household. Parents were from Eastern Europe. They immigrated over, the father immigrated over, the mother was already here around Ellis Island times. Vera was born in 1928, Philadelphia. Then they moved to D.C. later on. We think this is in Philadelphia, but it might be in Washington. We think it's in Philadelphia, though, because it was a family gathering. There's still members of the family in Philadelphia. And she's 10 years old over on the left. All right? Isn't that cool? Decades later, Vera Rubin would go on and figure out that most of the matter in the universe is not made up of protons, neutrons, and electrons. This so-called dark matter outweighs us, the matter we're made up of, by several factors. For every pound of stuff made up of protons, neutrons, and electrons, there are 4 or 5 pounds of stuff out there, very thinly spread out. Maybe 10 particles per the volume of this entire room. But all added up together far outweigh us and the stars and the nebulae and things like that. Really quite amazing, right? And it's quite appropriate that Vera Rubin is the person after whom this observatory would be named. The National Science Foundation, who was the primary funder of this project in collaboration with all the international partners and the universities all around the country and around the world, agreed, you know what, let's honor Vera with this. That's the Vera Rubin Observatory. Kind of looks like a star base on a distant asteroid, doesn't it? I think it's really kind of cool. But what might surprise you is this is a nighttime photograph. This is taken with a long exposure, just a few seconds, in the dark with a sophisticated, fancy, but just an SLR camera, one that you can buy off the shelf. And the reason you can tell is that, see that light there? Those are human beings. Those are habitations far, far away. This is on a mountain in Chile called Cerro Pachón, in an area of the world where the atmosphere flows in such a way that it drives rain away from the mountaintops instead of toward them. So it's really quite remarkable, and it's a wonderful place. This telescope is about 30 feet across, and it's that many stories tall, right? Imagine a 30-foot telescope in there. And on its back end is a camera somewhat larger than a pickup truck that has 3,200,000,000 pixels on it, on 189 chips. And every 30 seconds, it's going to take a picture of the night sky for 10 years, if the weather allows. This is an amazing result, more than 1 trillion pixels a night. And it's going to change and revolutionize all the things that we're going to find about stuff out there, including, I believe, the concept of biosignatures, right? When we're looking in our own solar system, we're going to have things like Dragonfly, which is a spacecraft that's being developed now. It'll launch in about 10 years. It'll get to Saturn's moon Titan about 7 years after that. And for about 10 years, it will flit around as a helicopter around Saturn's moon Titan, where temperatures are hundreds of degrees below zero, but have all the chemical compositions that might lead to life as we know it here on Earth. Pretty cool, right? Here, the Rubin is going to look at other worlds, other telescopes, and other places, other solar systems, and see if we can find changes in their light that would indicate some sort of civilization or some sort of technology. That's just one way. There'll be many, many ways that they're going to do this. Here's a movie I'd like you to see. This particular movie, if it doesn't play now, we'll play it in the Q&A session. Just 100 asteroids, but 2,000 in just 10 hours. Look at the field. These are all the things that were discovered moving around in our solar system between the orbits of Mars and Jupiter in just 10 hours. You zoom out and you can see that compared to the entire solar system, all that we looked at was this little tiny sliver of the asteroid belt. By the time the Rubin Observatory's 10-year survey is finished, we will have discovered 5 million new asteroids just in our solar system alone. One of my colleagues said to the press, it was almost too easy. It felt like cheating. It was like fishing in a barrel. Think of that, 5 million, each one of these rocks possibly containing fossilized information, not of life, but of the ingredients of life. What can we do to study all these things? To know whether or not we can find that extraterrestrial life out there? Wouldn't it be cool if we did? But you know what? There are only about 8,000 astronomers in the world today. By astronomer, in this case, I mean people who are trained in the sciences and actually making a living doing astronomical research or telescopic observations or things like that. There's only about 8,000 of us, and there are 8 billion people in the world. So just so you know, we're kind of 1 in a million. It's good. But what I'm saying is, we can't do it by ourselves. We need help. You guys can all do it. And we can talk about that in the Q&A session, because there are ways where we're setting up with the Rubin Observatory so that you can participate. You too can make these discoveries. And because it was funded majorly by the United States government's National Science Foundation, you can all do it for free. Pretty cool, right? All right. So anyway, on to scientific prediction number 2. This one and the next one might be a little concerning to you. And I don't have as many pretty pictures for it. So we're just going to talk about it a little bit more, and I hope that's okay. But I want you to suspend your concern in my conversation, but just try to absorb a little bit of what I'm talking about here. The world will keep getting warmer, okay? If you make the calculation, this is a very simple calculation, just a few short formulas. You compare the data, right, the facts organized into data, from the past 100 or so years of the world's temperatures. You compare the past 70 or 80 years of data taken using both NASA and European Space Agency and other places in the world, their scientific measurements about the carbon dioxide levels in our atmospheres, other kinds of things like methane, other amounts of heat generation that we have here. And you don't have to say anything about what we humans are going to do in the next 25 years. And you can already calculate the statement that is on the board now. Between about 1900 and today, 2025, the mean atmospheric temperature on our Earth's entire atmosphere has gone up about 3 degrees Fahrenheit, a little bit more than 1 degree Celsius, okay? It varies from here to here, right? Some places have actually gotten colder. But the majority of places in the world, overall, as a measurement, the temperature has gone up by about that much. If you multiply that by the heat capacity of the Earth's atmosphere, and you multiply that by the actual mass of the Earth's atmosphere, how much atmosphere there is, and the calculation is that compared to the year 1900, the amount of extra heat bouncing around in our atmosphere is equivalent to approximately 100 million Hiroshima atomic bombs. 100 million of them. Now, feels dangerous, doesn't it? 100 million atomic bombs going off would be really bad. Fortunately, this has taken a long time, right? An atomic bomb releases the vast majority of its energy within a fraction of a second. This has taken a century. So we have not suffered total disaster and catastrophe immediately. Instead, what has happened is all that energy flowing around is now part of our ecosystem. It's not going away. And in fact, in the next 25 years, we will add more to it. We do not know if it will be 100 million or 200 million or 50 million extra atomic bombs worth of energy floating around in our atmosphere, but it's there, and it's not going away. The sun keeps shining. It always shines more on Earth than we retain on Earth. So amount bounces off, eventually gets reprocessed, and gets out of our atmosphere. But this carbon dioxide that we have in there now, this heat that's there now, it's like having a comforter on a cold night in Erie when the wind is blowing off the lake, right? We can take off the comforter once we get warm enough. Earth can't. So these 100 million atomic bombs worth of energy are bouncing around right now. And every once in a while, a few million of those atomic bombs do something, because the Earth is a very dynamic environment, so it changes back and forth a lot. What does it do? Oh, I don't know. It could gather up into a hurricane, right? Or it could create a polar vortex. It could melt ice here. It could make that part colder. It could change weather patterns over years and decades. The western United States is already in a generations-long drought. And then after a decade's worth of drought, there was a massive amount of snowfall. And then there were floods coming down the mountains. And then this past year, there were wildfires in very rich areas of Los Angeles, Pasadena, and elsewhere. People were powerless to stop it. That's because those are millions of atomic bombs worth of energy being deposited or distributed in ways we can't predict yet. And that's going to happen every single year between now and 2050. You probably saw some of the incredibly devastating damage in Hurricane Helene created in North Carolina and Tennessee, of all places, hundreds of miles away from the ocean. That stuff is normally predicted to have less than 0.1% chance of happening in any given hurricane season, that kind of disaster. Well, now that odds have just gone up, everybody. This is what we're going to live with. And again, it doesn't matter what your opinion is. It doesn't matter what my ideology is. That's there. That's my prediction, and that's based on science. And not just my science, and not just 10 people's science or 100 people's science, right? That is the nature of things. So my prediction is, well, will it be 200 million atomic bombs in the future? I think by 2050, based on the models that I have seen, it'll be like 120 to 150 million atomic bombs worth of extra energy floating around. And just ask yourself, how are you going to account for all that extra energy bouncing around our atmosphere for the next 25 years? Our world is warming, there's no doubt about it. Right? So that's my prediction. Do we have a future here in 25 years? That's a question that we're asking, isn't it? There are these climate conferences, meetings happening all the time, right? And people are working really hard to try to figure out how we can stop this global warming phenomenon, right? How can we stop the climate change that is being caused by this global warming? Those are all noble and good things to think about because it's very important. Otherwise, by the year 2075 or the year 2100, maybe there will be 200 million atomic bombs worth of heat, 300 million atomic bombs worth of heat. But that I can't predict yet, right? All I want to know is, are we going to be okay in 25 years? What's going to happen to our lives? Are we gone? Are we toast? No. But I'll explain why later, okay? Because we got to get to our third prediction. Our lives and ourselves, our sense of who we are and what it means to be human, will be changed by artificial intelligence. What is AI exactly, everybody? Is it some cute little computer program that you can type in, right? Is it E.T. phone home, right? Is it the thing that so many of my students think that they can just type test questions into and get the answers out so that they don't have to study, right? The answer is all of the above. Artificial intelligence is as complicated and difficult to explain as natural intelligence. In fact, it's probably easier to explain because we, who are naturally intelligent, invented it. The thing is, we invented a way to let the artificial intelligence software develop without our supervision. It's kind of like parenthood a little bit. It's kind of scary, right? We tell our kids, we want you to be whatever, happy. And then we say, you have to be a doctor to be happy, right? Fortunately, my parents didn't do that to me. But nevertheless, we realize as adults that what we really want for our kids is for them to be happy and for us to be able to brag about them. That we can be proud of you, that you can be respected in your community, that I can say, yeah, that person's my kid, and be really good about that. That's what we really want, whether we thought we did at the time or not, right? AI is like that. Are we going to be proud of what artificial intelligence provides in the future? This is the world's most accurate quantum computer, at least according to the company that built it. Okay. Now, the company who built it, by coincidence, happens to employ as chief scientist my first cousin. Okay. So, I might believe it, but it's very specific. Yes. Remember, if you have more questions, get more cards. If you have questions already written, hand the cards in and get another card, okay? Flip them back and forth. We'll collect them all later. Go for the questions. Very, very important. We've only got about 6 minutes, 5 minutes left, so, okay? Keep working. Is this thing going to change our lives completely? Is it going to turn us into irrelevant things, right? What I tell my students always about AI is that it is a tool that we humans created to make life better for us humans, right? It's like the plow. It's like the tractor. It's like the car. It's like the airplane. It will change our lives. It will make us completely different in terms of what we depend on, what we do day to day, and what we have to do day to day. And if we don't adapt, if we don't notice it and work on it, we will be made irrelevant. Young people, you all know the term mid. Those of us who are not down with the lingo, okay? See, that means I'm really not down with the lingo if I say the term I'm down with the lingo, right? Mid means just meh. Ordinary. It is, in fact, one of the greatest insults that Gen Z and Gen Alpha will give to us, millennials and Gen Xers. You're just normal. And I tell my students is, when you graduate, you have to be better than ChatGPT. College is your opportunity to set yourself up in the future so that you are not irrelevant, so that you are not mid, so that you will not be one of the estimated 50% of young workers whose jobs will be doable with AI. Okay. So anyway, you might be a little afraid. In these last 4 minutes, I would say, should you be afraid? Are you afraid? Anyone remember that Jeff Goldblum, Gina Davis version of The Fly? He's like, don't be afraid. She barges in the door and says, be afraid. Be very afraid. So, is AI going to mess us up? Climate change is going to mess us up? Is aliens going to mess us up? Yeah? Nah. Here's why. I am very, very optimistic. I am realistic, and therefore I worry a little bit It's like for my kids, right? I worry about them a little bit, but I am not afraid for them because, thank goodness, I did them no harm. I let them do what they did. I helped them get to where they wanted to go. And then I said, fly, be free. Good luck, right? It's the future. It's the young people that make me not worried. Young people, and some of us old people that are trying to help, right? Let's give ourselves some credit. We should not be ageist. Very, very important. Looking at challenges, looking for solutions. We know via science and via history and via our learning, art, all kinds of music, all kinds of expression. We know how to look for the solutions. And surprisingly, we human beings have done a pretty good job over the centuries and millennia not quitting, always trying to do something else. There will likely be pain. There will likely be difficulty. But every community, every person goes through that to some extent or another. And if we remember that and say, I know how to think about the future. I want to tell you, I want to do something. It will be done. This is actually what I think about when I think of the Rubin Observatory. Not that beautiful piece of technology, but all the people sitting. This is about a 15-year-old photograph of many of my friends who worked on all of this great stuff. These are the people that made these discoveries or future discoveries possible. It's the people that I believe in most. Thank you very much. I do have a few more slides later if we want. But for now, we're going to go to the Q&A, and I think Ben is coming up. And how many of you remember a great Pittsburgh native named Fred Rogers? Yeah. Do you remember what he used to do when he came in the door? It's a beautiful day in this neighborhood. Beautiful day for a neighbor. Would you be mine? Could you be mine? I have always wanted to have a neighbor just like you. I've always wanted to be with you, so let's make the most of this beautiful day. And while we're all at it, might as well say, would you be mine? Could you be mine? Won't you be my neighbor? I got to do this with a microphone, guys. Can you guys all sing with me? Won't you be, please won't you be my neighbor? Hi, Ben.
So Dr. Liu, if it's okay, I'll join you. I'm going to take my tie off as well. We're going to settle in. We're going to have a great conversation, no doubt made even greater by questions from you, the audience. So you may see our team members going around, collect as many as you can. We're getting comfortable. If you're wearing a tie, feel free to take that off. If you brought your own sweater, feel free to put that on. I'm so glad that you went there, yeah. Dr. Liu, because
Thanks.
As someone who grew up both south of Pittsburgh and in the viewing area, and somebody who grew up on PBS, Fred Rogers meant a lot to me. And I think it was chiefly because he made the world accessible to me. Beyond that, what I knew of my very small town in which I grew up.
Yeah.
One of the things I appreciate about you is how you make the universe accessible to us. And so I can't help but to also make sure we mention not one but two books we will have available for sale and signing here with us. One of them, Intro to Physics for Babies. Why write a physics book for babies to help make it accessible? Let's start there.
This is a great question. How many of you who have been parents remember your little child grabbing a piece of food or a fork from the high chair and tossing it over the side? Guess what that baby is doing? a physics experiment. You see, we have learned, unfortunately, a lesson which I think we should all try to unlearn, and that is physics is hard. That somehow math and science are foreign to us. I disagree completely. The main issue is just the language barrier. If I got off an airplane in, I don't know, St. Petersburg or something, I don't speak Russian, I can't read Cyrillic, I probably couldn't even find the restroom in the hotel terminal, or in the airport terminal, right? It takes me years, but over time, if I try, someday I'll be able to figure out directions, then I'll be able to read a newspaper, and then someday, much later, I'll be able to laugh at the jokes. I laugh at physics jokes, and it's awesome. But that's because I've spent my life learning that language. If we can start with children and their parents feeling like physics is fun, it's a little doggy and a little cat running around chasing things, trying to solve a problem, solving the problem, and then their friend the mouse, runs off with their toys. Love it. And let's keep doing that. And you all, please remember, if you think that you hate math or hate physics, or it's too hard for you, or your parents are lawyers, so there's no way you can learn it, you don't have a brain for it, whatever, right? Just remember, that's not what you actually hated. It was class that you hated. It was tests. It was artificial ways of trying to measure you against somebody else with some number that no one cares about anymore. So enjoy the physics, enjoy the science, enjoy the math for what it is in whatever language you can receive it in. And I, hopefully through this book and my other books and all that, and my talking here, will help you feel that way too.
And of course, for the adults, we have the Handy Quantum Physics Answer Book. A great resource, again, making things accessible. Dr. Liu, we appreciate you, and here we are trying to be realistic, perhaps be optimistic about the future and where we are headed. I want to go back to the will we be here, because we're talking about our warming world. So one, I'm curious, have we reached that point, that tipping point? There is no going back. We're not slowing down the atomic bomb's worth of energy. And then ask you the question you posed yourself. Will we still be here in 25 years? Tipping point, will we be here?
Yes, we will still be here, even though we will have reached a tipping point of sorts. The tipping point is whether or not we will be able to reverse what we did within a human lifetime. Make sense? We could reverse it in 1,000 years, but that might not help us very much, right? Can we reverse it, say, just by stopping using all fossil fuels? No. We should do that, that would be great if we could, because then that prevents further catastrophe. So the tipping point has been reached, but the time point is one thing I want to make with you all. We're thinking about one human lifetime, maybe 2, our children, maybe 3, our grandchildren, right? But what is actually happening? On our Earth, there have been times, millions of years worth of times, in fact, where the temperature was much hotter than it is now, where we had no polar ice caps, and in fact, all we had were jungles and deserts and oceans. We weren't around then. The dinosaurs were around during one such warm period, right? That has changed. There's also been many times on Earth over the millions of years of geological history where Earth was a snowball. There was no place on Earth that was not covered by ice or snow. These things have been regulated in almost all cases that we can figure out by the amount of carbon dioxide in our atmosphere. And so our atmosphere's carbon dioxide levels have a rhythm, and every once in a while they shoot up and they change things. But those shoot-ups usually take thousands or millions of years, and then the shoot downs as they cold back down to snowball Earth or something, also take thousands or millions of years. We humans are an amazing species, though. We've been able to do this in just a couple of centuries. So we know what's going to happen. We've hit the tipping point where in these 200 years we've done so much to our climate that we're not going to be able to reverse it in 50 or 100 years. It's not going to happen anymore. But life has existed even in hotter times, and so will we. It'll just be a matter of how we do it. Will we do it so that all human beings will still be okay? Or are we going to allow millions of people to suffer as a result? Right? Will we be some of the millions? It depends on the decisions we make. Will we suffer the consequences if we're okay, but millions of others die or are displaced or are wrenched into poverty or famine? Right? Well, desperate people do desperate things. And maybe that's why we are so vulnerable to some people suffering. Because when some of us suffer, all of us have the potential to suffer because of it.
Several questions following up on climate change and how we might react to it and how we might move in the future.
Sure.
And I think trying to sum up several of them, it is which do you see science progressing in a way that we focus our intention on saving the planet or preserving it, some sort of shield around us, efforts to cool the warming, or do we inhabit somewhere else first and focus our energy there? Or is this a both moment that we pursue both? Where do you see this crisis driving scientists? Preserve the Earth, explore the outer reaches?
An incredibly good composite question. Is science moving in the right direction? Yes. Scientific progress is moving toward an ability for all of us humans to be able to find an excellent solution or set of solutions to all these problems. Is science policy moving in the right direction? No, it is not. Science policy is determined by whatever we, if we elect our governments, or those who run the government, whether or not they're elected, what their priorities are. If we can influence science policy in such a way as to say this matters to us all, then that is the direction it will go. Okay? Think about the light bulb. I'll just use that as an example, and then we can launch into space from light bulbs, okay? The light bulb originally was invented not to save energy. It was invented so that we could do business at night, right? So factories could stay open, so businesses could continue to work, so there could be growth in our economy. So all of our subsidies in our government has gone to keeping the lights on, right? Totally understandable. Now we have an issue, don't we? If we keep the lights on like we have always had, but we have this many more people and these many more demands on our stuff, we are going to cause even more environmental degradation and threaten our ability to live the way we would like to. Well, guess what? During this period of time, scientists invented the LED bulb and invented the compact fluorescent bulb. And while they didn't get any subsidies at all, guys, right? There was none of that. All they were caring about, like, get those bulbs going. Get those 100 watts, get those 200 watts, get those incandescents, get all that stuff going. Well, I read somewhere recently, and I think this is true because I did a back-of-the-envelope calculation myself, that the changes that we in America alone have done by changing our light bulbs from incandescent to LED and compact fluorescence has actually saved more fossil fuels than every single electric car and solar panel and wind turbine put together in this country. Just those light bulbs. So you see, the science is there. And when we, as the people who need to live into the future, need to think about the future, make those decisions by ourselves, even if the science policy isn't supporting what we want, we can still make a difference. Because the science is there. And now if we are able to influence science policy and are willing to put ourselves out there and do that, then maybe the policy changes too. Wouldn't that be cool? Space, the final frontier.
So let's use that as a perfect segue to the most accurate science fiction you've read or watched. People are wondering what you've looked to for guidance. And perhaps there's even the relationship of how science fiction informs science, or how we bend our science around the science fiction we have access to. So accurate science fiction, what you're reading, what you're watching.
Wonderful.
Is it informing science?
Wonderful, 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 wonderful.
They're a great group, I told you.
You are. I'm really glad I came to Erie. See, I told you I wanted to come to Erie. This is why. No, this is a great place. It really is. I'm amazed. I knew it would be cool when I got here, but so far I've been even happier with it than I thought I would be. Every science fiction author or creator gets some things right because they base their stories on the things that they're pretty much thinking are going to be right. Does that make sense? But every science fiction writer also knows that they're going to get stuff wrong. And sometimes they get stuff wrong on purpose. Because they're going to start with something, some assumption, and then take it to its logical conclusion, and then take it to its illogical conclusion. And that's what makes the science fiction so interesting. So I look to all the science fiction that I see to look for both inspiration and prediction. Star Trek, for example, right? We'll just use Star Trek as an example because there are too many other things to say, but there's so many, right? When Star Trek first invented the concept of warp drive, it was because the writers knew that we could not travel faster than the speed of light, but we wanted to get to interesting planets. So how are you going to do that? The nearest planet that we know of outside our solar system would take our fastest spacecraft 80,000 years to get there. Wouldn't be much of a plot, right? Kirk wouldn't be, star date, my granddaughter is about to turn 4. That's not going to happen. So they invented faster than light travel. Also, they didn't want to spend time on shuttlecraft going down from the big ship down to the planet's surface. So they invented the transporter. They also didn't want to not be able to talk to people. So they invented the communicator, right? All of these things were invented to further the story. Well, it turns out we still don't have faster than light travel, right? That was wrong. Turns out we still can't transport people, although there is a thing called quantum teleportation, which I would be happy to talk to you guys about. It's kind of cool, okay? But it's not beam me up, Scotty. It's a matter of transferring information in a quantum-based way. But you know what? We do have communicators, right? Those ideas inspired us to think and wonder, what can we do? So we're still going to keep working on warp drive. We're still going to keep working on non-quantum teleportation. But we already worked on the communicator, and we haven't. So that's where we got to go. I think all kinds of science fiction have their great value, even dystopian stuff, right? Because they warn us what would happen if we take something to its illogical conclusion. What is going to happen under those circumstances? The Expanse recently has gotten a lot of positive press, right? There are lots of other things. Star Wars is really more of a fictional fantasy story, an opera, right, rather than science. But that's okay. I still like it, right? Because it's still inspirational. And then the fact that science fiction can inspire things other than science is something that I never take for granted. In Star Trek, most of you know that there is a thing called the Prime Directive. There's a thing called being at peace and harmony with one another, feeling like that all humans and even all non-humans can coexist in harmony and work together and be together in an environment and look different and be different and act different and talk different and even breathe different, and yet still be part of one peaceful and joyful community? That's pretty inspiring. We haven't gotten there yet either. That's not scientific, that's human. That's a different thing. But you know, I go to Star Trek conventions, not just because I get invited, but because actually it's fun. And you go to those folks and you hear them talk, and you hear them with the audience members, with the actors. And the actors even say, we were so inspired by being on this show. When I first got this show, I just thought it was a meal ticket. But then I realized, wow, I am communicating something far greater. A hopeful future, an optimistic future, a realistic future, but something that we can all think about in the future. That's not so bad, right? That's where the science fiction comes in, everywhere. Thank you. What a great question, everybody.
Let's turn to real science. We have interstellar visitors like Oumuamua and more recently the Atlas comet. Why are they moving so fast? And that is capitalized, underlined 3 times in our outer space. This person's very concerned about that. Why are they moving so fast that they seem to be defying our gravity?
Great question. For context, for those of you who are not aware, in the past few years, astronomers have discovered 3, at least, asteroids or comets that are going through our solar system. They're not actually orbiting in our solar system, not like the millions that we're going to discover with the Rubin Observatory, but these originated far, far away. And then they're zipping through our solar system so fast that they will not fall into orbit here on Earth or around the sun. They'll just keep going. They're going to be affected by our path. They'll get curved a little bit. They'll get slingshotted or something like that. But they're not going to stay. How can they get so fast? It's because they're not dependent on our gravity. They are dependent on the gravity of the entire galaxy. It is easy if you have enough time to send an object like an asteroid or something like that, or a big dirty ice ball, or an icy dirt ball, right? A few miles across, whatever. Send it flying out of a solar system, and then going past another solar system and getting a boost in speed from that one, and then going past another solar system, getting a boost of speed in that one. This process could take millions or even billions of years, but it is actually very easy to speed up something that fast in our galaxy. It's going to go zipping by. We'll be able to wave at it and go, bye, see ya. And it'll do the same thing to us, you know, if it had a mouth. That, of course, how many of you enjoyed the Sesame Street episode where Zoe has a pet rock named Rocco? And Rocco doesn't even have a mouth, right? Now, Elmo is complaining because Zoe is saving a piece of cookie, or the last cookie or something for Rocco. And he's like, well, I don't know, I think Rocco may want it. And Elmo's like, Rocco doesn't even have a mouth! You guys remember that? I'm sorry, I just wanted to bring that in for fun. In a way, Sesame Street is its own sort of alien civilization, isn't it? But a wonderful one. So that's the answer. Physics actually makes it quite easy. The problem is that there are people who would rather believe otherwise, and they will not tell you that that's that easy. And they just won't say it. They prefer to think of something else. And then that gives those folks some notoriety or some confirmation or something. And they're like, yeah, I knew it, right? We humans have this thing called confirmation bias, right? We tend to believe what we want to believe much more than what we don't. So we can have 100 pieces of evidence saying that our favorite belief is not correct, but we get one piece of evidence that says it is correct, and they'll be like, I knew it, see? That's what we all do. It's a fundamental thing about our existence. We know that about our human brains. But the confirmation bias is strong with this one.
Shifting for a second to population.
Yeah.
Some people are concerned that we're going to see a continued decline in population. Others are concerned that we're going to overpopulate the world. Others are wondering if we continue to increase our population, we're about to experience superabundance, in which we produce smarter people to figure out more problems and challenges. Where do you lie?
Wonderful question. I am not a researcher in demographics and biology in that respect, but I have friends who are, and I really respect their work, and I like reading what they have to say. The story apparently is that we human beings are overpopulating parts of the world and underpopulating others, okay? The process has been throughout all of our society that the more prosperous, by our current standards of prosperity, that a society gets, the lower its birth rate becomes. That's just how it goes. Things get more expensive, kids get more expensive. Instead of having to have kids to make sure you have surviving kids, they all live, and therefore you want to do what's best for them, and so you add more and more to their education and to their material needs and to their educational needs. You just wind up having fewer kids. That's just how it is. And then you have your own life to live. You get to enjoy your own life with those few kids instead of spending your whole life taking care of kids, hoping that a few of them will live so that you'll be able to pass down your DNA, right? It's just a pattern of all species, and humans are not immune from that. What does that mean? The United States currently does not have enough live births to replenish its population. If we only rely on births, it doesn't matter if you try to do a rah-rah, have more kids kind of thing, all right? It's not going to replace our population. Places like Japan, South Korea, they're in an even worse situation. China, their population is dropping. Our population is growing, but just ever so slightly. Their population is dropping by millions each year. And because they had their one-child policy for so long, it doesn't matter, even though they're right now saying, be patriotic for China, have more kids. It's not happening, right? That's going to be another at least quarter century before their population starts to grow again. But in the United States, we have actually been okay with our population because we are a nation of immigrants. Because we have, even under, administrations or public policies that seem to discourage immigrants, we actually encourage immigrants really well compared to most other nations in this world. So where the population is growing are places like sub-Saharan Africa, parts of South Asia, places that are not as prosperous, parts of the Middle East. These places will be burgeoning with people. And if there's a lesson that we've learned in American history, it is that when we welcome immigrants, even though at first it's a challenge, even though at first they are, treated as scapegoats, treated as subhuman, treated as, people that we don't want around, eventually they wind up enriching our country and becoming something amazing. I look around just here in Erie right now in this room, and I see the result of 7, 8, 9, 10 generations of immigration, right? Very few countries in this world can claim that. There will be an 11th and a 12th and a 13th generation, and it will come from different places, but they will enrich us as well. And so our population worldwide will continue to grow. It's about 8 billion now. The demographic predictions are that they will get to about 9 or 10 billion and then level off. And at that point, we will just have a cycle worldwide where people who leave this world will be replaced by people who enter this world right about equilibrium. And then that superabundance can really take hold, and then we can think about other places to immigrate to. Maybe Mars.
And one of the things to note here in Erie County, a growing demographic, new Americans, when it comes to population growth in our city in particular. So we are a welcoming city. So I think we are heeding that and working on our diversity.
Awesome! Another reason why Erie is awesome.
A round of applause for our audience for all of these great questions. I am trying to get through as many of them as I can. This, to me, is having been an English major here at Gannon University, strikes me as a Robert Frost fire or ice kind of question. Yes. Nuclear obliteration, environmental collapse, asteroid. What is likely to happen first?
You guys all know Fire and Ice by Robert Frost? Some say the world will end in fire. Some say in ice. For those, from what I've tasted of desire, I stand with those who favor fire. But if it had to perish twice, I think I know enough of hate to know that for destruction, ice is also great and would suffice. He was talking about the human condition, of course. Do we have passion, or do we have distance and isolation? I think that the fact that for the past 80 years, we have avoided nuclear catastrophe on a species-wide scale is good evidence that we will continue to avoid it. So I am not worried about nuclear destruction of the human species. I am worried more than I was, say, 20 years ago about proliferation and about the possibility that somebody will do something terrible in some city or some place, possibly because they've been radicalized, because they have been driven into poverty and starvation, due to, I don't know, could be war, could be famine, could be disease, it could be global warming, whatever, right? I'm more worried about that than I was a few years ago. But as far as species-wide devastation, I think the nuclear thing is temporarily off the table. As far as an asteroid hitting us is concerned, right now, again, based on the odds in our research, the odds are in any given year that an asteroid that could threaten human civilization will hit Earth are about 50 million to 1 against. So that in any given year, we should be okay. But, people do sometimes win the Powerball, right? So if we, as scientists, we already know that we can track asteroids. If we had the resources, or if governments decided that 50 million to 1 odds were high enough that you have to worry about it, then we might want to write an insurance policy, right? Thanks, Erie. Write an insurance policy to provide enough research and enough time and human resources into looking for this at just the right amount of money that makes it sustainable, but also not a waste, right? And then we can watch these things and we will have enough warning, could be a year, could be a decade, to see them coming and then remove them. So I guess the answer to that question is, are we going to do something about it or not? If we don't do anything about it, the odds of that causing us destruction are higher than the odds of something like nuclear stuff. But that's because we already did something as a society about nuclear stuff. If we do something about the asteroid hit thing, we'll be okay. And the same is true with this climate disaster. If we all do something about it, we'll be okay.
I want to dive more into what we can do. We'll come back to that. I want to shift to AI because we talked about that as a big part. People are concerned about I think you mentioned 15% of jobs. What are we doing today? What should we be doing tomorrow? That's the gist of the questions. How are we anticipating this? And what does our history teach us, right? Because we've seen seismic changes in economies, in the way that we produce, in the way that we consume information. Does history teach us anything that's relevant now that we must be learning? What should we be doing anticipating the change of jobs with the impact of AI?
An incredibly good question, and I have actually tried to think about this a great deal. We think about other changes in civilizations, massive, huge changes, and what did it do? In 1905, for example, horses were the way you got around, right? By 1935, cars were the way you got around. But in 1905, or thereabouts as I recall, there was a scientist who made some calculations and predicted that if we don't change, then there will be so much horse manure on the streets of New York City that we humans would not be able to survive. Not like stacked up to the roof, but just you have to like step all around it. It was gross. Already by that point, there were like piles of horse manure all along the streets and everything. It was really gross when it rained, right? Well, obviously by 1930, we'll just use 25-year interval, right? That problem was solved. There were no more horse manures. But there were also no more horse riders, horse groomers, horse feeders, right? Now, horses, of course, still exist today, but it's a very niche kind of thing. So if you loved horses and you wanted to keep working with horses, you could still do it. You just have to look very carefully. You find a different thing. Maybe you go to Pimlico, in Maryland or something like that. You can do it. But if you wanted to preserve that thing you enjoyed so much, then you would have to adapt accordingly. Meanwhile, what did that internal combustion engine vehicle usher in? An entire age of new prosperity. Ford Model Ts, our ability to move around the world. Now, this immigration thing, right? Railroads had been turned into cars. We have this integrated highway system. All of that, a huge amount of our economy was switched as a result. And that's because people who saw that the change was coming, those people did not hide their heads in the sand and say, we must preserve the horse industry. There were still plenty of lobbyists and people who were saying like, no, you can't put these cars in. We got to do the horse industry, right? That didn't work. So this is what AI is telling us now. What is AI able to do that we cannot do? That's what we have to think about. How do we use AI? In my astronomy classes and my research classes, I actually allow my students to use ChatGPT and Google Gemini and Perplexity.ai in their homework and on their exams. I say, you are welcome to do it, but the questions I ask then become the ones that need you, the student, to answer, even with using AI as a tool. So I'm not going to ask you something that if you just type it into ChatGPT, you'll get an answer out. I don't even know if that answer is right? In fact, ChatGPT is still getting about 25 to 30% of its answers wrong. And you can't find out where that went wrong. You don't know where it got its information. It doesn't know where it got its information, right? So that's what's going to happen. You have to be better than ChatGPT. These jobs, these millions of jobs that can be replaced, data entry work, okay, telemarketing work. Now, this is an interesting one that I had not considered at all until I heard this on a news report of a person who was doing telemarketing, and I think it was on one of the financial channels. He said, right now, call centers for US-based helplines, like, my computer's broke, gotta fix it, what do I do? They are based in countries like the Philippines and in India because people speak English with an accent that most Americans can understand. So there's a huge call center business in Manila. Did you guys know that? I know there's already a big, call center business in Bangalore, right? You guys know this. But AI filters will now make it possible for someone who speaks with a very different English accent. Ordinary English will come out the other end of the phone. So now, call centers can go to even less expensive places where the labor is lower. Instead of the Philippines and Bangalore, they might go to Kenya. They might go to Rwanda. They might go to all kinds of new places. That's cool, right? But not so cool for the people who only know how to do call center in the Philippines. What do they have to do? They have to learn how to write the software that changes your voice. They have to be the ones that know how to have the knowledge to tell people what to do, regardless of what language or what accent you have. maybe they learn French, right? These are the things we have to adapt to. I cannot tell you, unfortunately, much as I would like to, because I don't know, what specific adaptations will be necessary. But I can tell you generally what's happening. Artists now are needed less and less. But a good artist who knows how to use AI in a way that enhances their art rather than just duplicate it will become even greater demand, right? Television producers, people who get paid 6 figures to put on your latest episode of Everybody Loves Raymond. I don't know. I think that's been canceled for a long time. Those folks can be replaced by software people just moving stuff around on their computers. So those producers instead need to produce not what they did produce, but something different, something better, something unusual, something that ChatGPT can't do yet. That's why I'm not worried, right? Because the people can adapt. If you are able to adapt, you will face tough times, right? Things can go bad for a generation. But if you're ready and if you remember the lessons of history, then you looking to the future, you can get guidance from the past and make whatever situation you're going to be in great. It might take a while, but it'll get there.
Dr. Liu, audience, we are, of course, up against the clock.
Already?
And we have an embarrassment of riches of great questions up here. We've scratched the surface. I'm hoping you're going to forgive me and let us go through just a few more. If you do have to leave, right, you can depart. But if, Dr. Liu, you're willing to stay and answer a few more live with us in the audience.
And let me remind you, I will take these all home, okay? And whatever we don't get on today, I will try to get onto a episode of the Luniverse podcast as soon as I can. All right? It might take a few months, but especially if you put your name on there, I can, read your name and we say, hey, so you have a question from the audience? Yes, this person in Erie, Pennsylvania asks.
And I think asking to wait 2 months is not asking too long if humanity is still going to be here in 25 years.
Bye, everybody. Thank you so much for coming. Thank you. Yep. And all the rest of you, stick around. Yeah, happy to talk more. Thank you so much.
Stick around for just a few more. Dr. Liu, you were talking about, and I think that was powerful, of thinking how to use AI responsibly.
Yes.
In the human component of working with a tool. So if we're using it responsibly, questions about how we're powering it responsibly. How do we make sure we are not consuming all of our resources to power data centers and servers and quantum computers and taking advantage of our natural resources?
What a great question. I think you all have a sense that when Google came online 25 years ago, the demands on our electric grid skyrocketed at that point. Search engines actually do take some energy. They've made some calculations, and every time you do a Google search, or an Uber Eats order, or an Amazon search, for some gift or whatever you're going to give this holiday season, it takes energy. And so right now we are using, just from that kind of data, something like 10 to 20 times more electricity than we did 25 years ago. Okay, just from those things, it's that much. So AI's jump is comparable. It requires anywhere estimated from about 3 to 20 times more energy to get a ChatGPT answer than it does a Google search, right? So this is not a new problem, it's just the next level up. There are 2 things that I can think of that can solve this problem. Okay, number 1, the electricity generation in our country can very, very slowly but surely be changed to things that are sustainable. We've talked about wind and solar for a long time. It is now cheaper to create a kilowatt of solar energy generation than it is a kilowatt of coal or oil or natural gas or even nuclear. Okay? There are people who are now saying, well, Microsoft has actually signed a contract to reinstate a nuclear power plant in Harrisburg, one of the 3 Mile Island piles that didn't actually come close to meltdown back when I was a kid, right? But that's going to take a decade before the first watt of power comes out of that plant. So if we were able to convince these folks really to just do the renewable stuff sooner rather than later, we would be able to help mitigate some of this problem. But again, that's still just mitigation, right? The second thing is actually us. Sensible and conscious use of AI. 90-something% of all AI queries right now, I read somewhere, I do not know for sure if this is true, I haven't checked it myself, but 90-something% are unnecessary. It's kind of like if you are hydrating, if you're drinking, right? And every time you had a bottle of water, you would drink one mouthful and throw the rest away. Like, lots of clean water lost, which is not good. And then there's that bottle that has to be recycled, and 90-something% of bottles don't get recycled in this country, you know, things like that. So we can actually choose. I myself have actually chosen very carefully never to use the Meta AI thing or, you know, Google AI thing. Gemini can give you an answer. Would you like to build in your AI into the query? You know, that kind of thing, right? Aside from the fact that they actually are using my questions and answers to train their AIs in the future without my permission, I'm also using a lot more energy. Slowly over time, we can add that in there. And it is my hope that all of you will train your children and grandchildren that AI is just a tool. And if there is a way that we can solve a problem with a hammer and a nail, as opposed to a nail gun, as opposed to a pile driver, right? And just know when to use what. That could be the most sustainable decision that we would make when it comes to that kind of technology. And I think for AI as well.
Dr. Liu, I'm going to close with 2 questions because I do want to get folks over to the book signing. We have, of course, the handy quantum physics answer book. If you have questions, this book has your answers. And of course, if you've got a little one in your life, the Intro to Physics for Babies, both are going to be available. Both are going to be signed by the wonderful Professor Liu over there. We have a Sharpie. We have several Sharpies.
We even have a Sharpie.
So we're going to make sure it happens. So I'm going to ask these 2 questions now, and then I'll go through some housekeeping so you can answer perhaps both at the same time. The first question goes back to your first prediction, extraterrestrial life. Are we ready as a species? Are we ready to know we are in fact not alone? Something we wrestle with often. That's the specific question to your predictions. The broad question is how can, and this comes from several people in the audience, how can we, and I include myself in the we, the non-scientist, but the science fans, the science enthusiasts, how can we help influence and shape science policy in a positive direction? In other words, what can we do? What's our role? So are we ready for extraterrestrial life and to know we're not alone? And what can we, the non-science but science fans, do to help? Before you answer that, I want to thank everybody for showing up tonight. You've been a lively audience. I think this is the first time I've taken a tie off on stage and been part of a Mr. Rogers song and learned so much and had so many questions, which will later be addressed in a podcast. This is awesome. I've had a great night. I hope you've had a great night too.
Thank you all so much. It has been wonderful.
And I promise we didn't script it this way, but this night is so great, it's like we have to take a night off or something. And in fact, we are. We don't have any events tomorrow, so take the night off, rest up, and then come back right here to Gannon University in the Yale room for a veteran journalist, author, political analyst Juan Williams, who will be talking about his latest book, New Prize for These Eyes, The Rise of America's Second Civil Rights Movement. And then join us as we conclude this week back at the JES on our campus for political analyst, award-winning man in many regards, Larry Sabato, political commentator, the director of the Center of Politics at the University of Virginia, talking about the medium is the message, media's influence on national politics. Of course, talking about races this year and races next year. Then, of course, we really do need a break, right, folks? Because it's been like 17, and this has been great, and there's a lot of events. We'll enjoy a holiday break. We'll come back in December 4th for Henry Louis Gates. That's at the Warner Theater. Do not sleep on getting, yes, endorsement
Skip
right
Gates
there.
is cool.
He's cool. This is an endorsement, a testimonial. Don't sleep on getting your tickets. We appreciate that. See you at the Warner Theater on Thursday, December 4th. Of course, a big thanks to the JES team, our Board of Trustees, all of our sponsors, including our partner here in the venue space, Gannon University, and tonight's event sponsor, Erie Insurance. Sandra, thank you for that wonderful introduction. Round of applause for all of those folks. I could say professor, I could say doctor. I'm going to say Mr. Liu for the Mr. Rogers effect. Mr. Liu, we're going to the final answer. Are we ready
It's
to know we are not
such a
alone?
good feeling to know you're alive. It's such a happy feeling. And deep down inside, and when you wake up ready to say, I think I'll meet an alien today. Here's the story, everybody. We are ready to meet aliens, but are our governments ready? We humans, I think we are. There are so many of us that we've known, that I've known and met over the years. I think it will be very exciting. But what does a group of people who have, say, what they perceive to be some sort of political or economic influence or wealth or power, would they consider it to be a threat? Right? So it ties in very well with the second half. What can we do about things? Right? You notice that when we talk about science fiction and we talk about civilizations in these kinds of futuristic scenarios or scientific predictions and so forth, we're always talking about us as a species. We don't talk about, like, what will happen, is the United States government ready for aliens to show up, right? When the aliens come, whether they're benevolent or whether they're violent or whatever, it's always about how all of us react to it. Same is true for something like a dread disease like a pandemic or whatever. The individual people who run countries or whatever, not as important as all the rest of us who decide what to do, what is the right thing to do, and then just go do it, right? So if we are going to be ready, let's say whoever is going to visit us, let's say we're going to assume now that it's not that we discover some sort of microbial life on the surface of Titan or in the deep down underground of Mars, which is the most likely thing that we'll do when we find extraterrestrial life for the first time. But let's say we encounter creatures that are approximately our same ability to reason, our ability to communicate, our ability to do technological stuff, to wage war or to engage in peaceful interaction. Let's say they're approximately the same as us. I think everybody in this room is ready, right? We are going to be able to tell people, hi, how's it going? Let's chat. Let's figure out what's going on. Oh, you need this, but I need that. Let's work it out, Oh, you think this. Oh, okay, well, I think that. Well, have a nice day. Let's have lunch tomorrow. That kind of thing. I think we are ready as a species. And what we have to do is influence those people who make decisions for many of us at a time to act in those ways that we know to be right. A lot of this has to do with like environmental stuff too. Like, what can we do to promote science? Go tell your kids, hey, there's this cool physics show on. Let's go take a watch, right? Not like, oh, physics is hard. Or oh, no, those guys, they don't know what they're talking about. I know the truth, right? Have that humility, as I try to have, and understanding, and say, hey, that's kind of cool over there. Let's find out. Let's learn. Let's make it part of our lives. And then, as far as environmental stuff is concerned, right, we're worried about our climate, our trash. Like long before we were worried about carbon dioxide in the air, we were worried about garbage, right? You guys all remember when the pogo came along? We have met the enemy and they is us, right? That was about trash and pollution, messing up the Okefenokee swamp, right? If every person in Erie, Pennsylvania, roughly, would just recycle one extra water bottle a week, never mind, like every single time, and like get every little scrap of paper in the 1 bin and the 2 bin and the 5 bin or whatever, right? If you just recycled one extra bottle a week that you saw on the ground or that you saw on a desk somewhere or you have in your kitchen, that's 5 million bottles a year, right? And that will do more, that we don't have to burn it or we don't have to landfill it or that we can recycle it, we can reuse it, whatever. That will do more for the environment than you can count, all right? I can tell you the specific numbers, but that's not what's important. We all individually act one little thing at a time, and our whole species will get the benefit. That's what I'd like you all to do. Thank you all so much.
Thank you, thank you, thank you. Folks, thank you. Remember, book sale and signing. We'll see you in the other room. Have a great night.